Hello again. In this video, we're going to practice finding inverses when they exist. We have two ways of finding an inverse. We have, if it's a 2 by 2, a formula, or we have this algorithm that works for any size, as long as it's an n by n matrix. So let's go ahead and look at practice problem number 1. It says use determinants to determine which of the matrices are invertible. I'm also just going to find the inverse just so we practice. So what is the determinant? The determinant of A, if you remember, we mentioned this in the last video, is the AD minus BC, where A, B, C, D is in those locations. So if we look at this, this would be 18 minus a negative 18, which happens to be 36. So this is invertible because if AD minus BC is not equal to 0, then it's invertible. To actually find the inverse, you can use the formula. So what is that? It's going to be 1 over that number, so it'll be 1 over 36. And we are going to then switch the A and the D. So this is going to be a 6 and this is going to be a 3. And then we're going to put negatives. So it's right there. We're going to put negatives. We're not going to switch the B and the C, just put negatives. So that would be a 9. And this would be a negative 2. So now multiplying 1 over 36 by every entry, you would. So if we went and did this the other way, just to show both the algorithm and the inverse is the same, how to do this the other way. So how to find A inverse is we're going to look at A slash I. So A slash I would be, you cannot switch the rows or anything until you write this. So then you go ahead and row reduce them. So I switched this to the second row, this to the first row, and I divided everything by 2. Now I'm going to get a 0 by multiplying the first row by negative 3 and adding it to the second row. Then I'm going to get a 1 in that position by dividing by negative 18. And you see when I divide everything by negative 18 or multiply by negative 1 over 18, you get that last row. Finally, to get the first row, we need to get a 0 there. So I'm going to multiply the second row by negative 3 and add it to the first. So when you do this, you get a 1, you get a 0. Here you get 3 over 18, which I realize is 1 over 6. I don't feel like redoing this video, so I'm just going to change this because I realize that that's a mistake because 6 over 36 is 1 over 6. So let's make that correct. And finally, 3 times 1/12 is negative 1/4. Added to 1/2 is 1/4. And you see, with that correction, it is the same. So you can practice B. And pause it, try it, and then I'll just post the solution. The question says use the determinants to tell which of the following are invertible, so you can do that. But go ahead and find the inverse. I don't care what method you use. So first answering the question, I looked at the determinant of A, and that was 20 minus 0, so it was invertible. And here's the two methods for finding A inverse, whether you use the formula or the algorithm. Notice they do come out the same. So let's try part C. C is a little different because if you look at the determinant of A, it's going to be, again, AD minus BC, 36, it's going to be 0. So therefore, it's not invertible. It does not have an inverse. You probably could stop there. the formula makes sense if we look at the formula. Right, 1 over 0 does not exist. But what if we did it this way? Especially with 3 by 3s, because we wouldn't know how to do that with a 3 by 3. So let's go ahead and try that way. So what I'm going to do is just make these smaller. So I'm going to divide everything by 3. I don't feel like getting fractions yet, so I'm just going to divide everything by 3 on the first row. And the second row, I'm going to divide everything by 2. Might as well, just 2. Divide by 2. Divide by 2. And then when I try to get that 0 in that second row, we multiply 1 by the first, add to the second, and we just really add them together, don't we? That would be 1/3, and this would be 1/2. Right here, this shows me that you can never get the identity. Therefore, another reason it is not invertible. A inverse does not exist. So let's go ahead and do practice problem number 2. Practice problem number 2. The only way you can do this one, you cannot use the formula, so you have to go for the algorithm. So I'm going to take AI. I do not know if the inverse exists because I do not have a formula, so this is the only way I gotta go. So what do we have here? So A is on the left, I is on the right, and we would like to make it the other way around. So let's first get a 0 by adding row 1 and row 2. So give you 0, 3, 5, 1, 1, and 0. Now let's get a 0 in that third column. I'm going to take -5 times the first row, add it to the third row to get 0, 10, -4 is 6, 5 and 5 is 10, -5 and 0. Oh, it's -5. 0, 0, and 0 plus 1 is 1. Now, I could get a 1 here, but I can see that 6 there, so I'm just going to multiply the second row by -2 and add it to the third to get 0, 0. Right there. We can stop because no matter what this is, it's a 3, -2. No matter what this is, we know that A inverse does not exist. Because you can't get the identity. There's not a 1 that can be gotten there. Let's do example 6, example 7 in the book, because that one does exist. So let's go ahead and look at that one. So doing the same thing, A/I, well, I'm just going to put a slash there. Just going to look at their example in the book. So we're going to take A and I and then try to get the other way around. I'm just going to add a line to theirs. So they got a 0, another 0, got the 1, there already was a 1, then the 0. So they did all the steps here, and then they got the 3 zeros here. You have to go all the way. And then whatever that is, we'll just add lines here. Whatever this answer is going to be the inverse. So that is one that does work. It's a long process. It's a good idea to check your answers. So they did a check here. They just looked at A inverse and they multiply them together. And if you do this, you'll see that you get the identity. They say it's not necessary to check the other way around because A is invertible. Once you get this, you know that that must be the inverse. So the other one better equal I as well. But you could check that if you want. So that is another example for you to try. And the last thing we're going to do is look at the the theorem of properties on inverses. One is the inverse of the inverse is back to A. So A is A inverse. If A is invertible matrix, then A inverse is invertible. So to show that, this is what we need to show. A inverse times some matrix equals I, and the other way around. And this actually happens since A was invertible if we replace A by C. The next one, this is kind of interesting, that if you take A times B and find the inverse, just like the transpose, you have to flip this. It's going to be B inverse times A inverse, not what you think, A inverse times B inverse. To show that, we know that the C of AB, right, we're looking for AB times some C to equal I. So let's see if it's this. And notice how if you rearrange and put the parentheses here, this is just an I because B is invertible. So it's an I, so that just goes away, giving us this, which is an I. It works. A similar calculation can be shown the other way around. And lastly, that the transpose of the inverse is the inverse of the transpose. You can look at this little proof there that's just as simple as the other ones. And that concludes this section.